Welcome to P. Clark Calc, Practical Calculus for the Busy Math Student. In this video we're going to take a look at an example of the product rule in action with a couple of algebraic factors. Here we're taking a look at the derivative of a polynomial function. It's two factors, x squared minus 2x plus 1 times x cubed minus 1. And one option would be to take an algebra first approach here and distribute and then use the basic rules, the power rule, sum and difference rule, and so on. But we're getting to the point where maybe that's not such a good idea when we have, larger polynomials. Here I have a trinomial times a binomial, or if it gets larger than that, maybe I don't want to go that way. And so we have another tool which is useful here, and it's just critical in a lot of other cases when you get different types of factors, called the product rule. And the product rule says if you have the derivative of two factors, u times v, then by definition of derivative, you can prove the result of that is u times v prime, or the first factor times the derivative of the second, plus v times u prime, the second factor times the derivative of the first. And most students like to look at it in this setting. When we say u and v, what are we talking about here? U and v are just, in calculus, they're just these dummy variables that mean any kind of a function of x. So here if we say that the factor u is the trinomial x squared minus 2x plus 1, and the factor v is the binomial x cubed minus 1. So each of those is a function of x. So that's what we mean when we say u times v. But to take it out of the function of x format when you write the rule, it just makes it cleaner and a little bit easier to memorize. So if you wish, you can kind of do the scratch work on the side and do your derivatives of what does u prime look like, right? So I say, well, the derivative of u itself would be done by the basic rules, right? Because I'm looking at a polynomial. So we have u prime is equal to 2x minus 2 plus 0. And then the derivative of v prime, is 3x squared plus 0, right? So we figure out what are these two smaller derivatives that are going to be part of my overall derivative f prime of x. And with practice, a lot of times we'll just do this as we go. But if you wish, or if it's a trickier case, you can go ahead and do that as scratch work on the side, and then just insert those into your derivative. So we're ready to go ahead then and apply the product rule. And so we walk it through. We say, well, we have the first factor, x squared minus 2x plus 1 times the derivative of the second. This is v prime 3x squared. And then to that, we're going to add vu prime. So v is x cubed minus 1. And the derivative of u prime, is 2x minus 2. So if all we need is to get some kind of a working version of the derivative, there it is. And we can go ahead and just label our parts here quickly. So this is my u and my v prime, part of my product, and then this is v and my u prime. Or just talk it through as you do it. First derivative of the second derivative of the first. You might see the product rule written in slightly different ways, and different textbooks are online, because if you look at it, everything is commutative there. I could reverse the order of the terms. That's not going to matter. I could reverse the order of the factors in the terms, and sometimes that's preferred in certain cases. That's okay too. But we just write it this way so we can memorize it. If we want to prove that this is all working, we could take a second, although, if I just am trying to figure out how the derivative rule works, this would be fine. I could take a second and clean it up afterwards and say, well, what does this look like? So if I want to say a polynomial in descending order, so if I distribute v prime through u on my first part, I have 3x to the fourth minus 6x to the third plus 3x squared. And then for the second part, we're foiling there, a couple of binomials. So we have 2x to the fourth minus 2x to the third minus 2x plus 2. And then if I combine my like terms, we can express the derivative as a polynomial in descending order. So that would be 5x to the fourth minus 8x to the third plus 3x squared minus 2x plus 2, if that's something that you would need. Again, when you're just learning derivatives and you just do them sometimes because you're trying to learn the rules, is the original form good enough, or what do you need to do with this? But if we wanted to expand it, that's what we have. And if you want to check your answer here, we can do it in this particular case because we are dealing with a case where we could do an algebra first approach. So if I do that, say, well, let's go ahead and do the distribution of the trinomial through the binomial. So that would give me x to the fifth minus x squared minus 2x to the fourth plus 2x plus x to the third minus 1. And then combine my like terms before I do the derivatives. This is still f of x here. So we have x to the fifth minus 2x to the fourth plus x to the third minus x squared plus 2x minus 1. So if we take that and we run our derivative by the simple rules, power rule and sum and difference and everything else, right, then we can see that we get the same result. 5x to the fourth minus 8x to the third plus 3x squared minus 2x plus 2, which is a nice way to convince yourself the product rule is working without grinding through the formal proof by the limit definition of the derivative, which is true and it does support this rule, but it can be a little tricky to look at and a little hard to look at when you're just trying to learn derivative rules to get by. So at this point of your calculus career, a lot of times you look at the product rule and say, well, why would I need it? Because I can algebraically work around it. And you just have to understand that there are certain cases down the road where this is not possible, where I can't do a rewrite. For instance, if you had a function that had a polynomial factor, say x to the second, and say an exponential like e to the x, at that point there's no, where would you go with that if you didn't have a product rule? So we're not going to do that one right now, but that is a case where the product rule is mandatory. So that's it. That's the product rule, important rule for taking derivatives, and in this example we see it used in conjunction with a couple of algebraic factors. If you'd like to learn more about the product rule or derivatives in general, you can find that on my textbooks available on Amazon for a nice price. And don't forget to subscribe to the P. Clark Calc channel if you liked it. Until next time, I'm P. Clark.